G'day. So in this video we're going to start to look at creating a record of the experiment. So you can record the subject's responses and you can do some calculations, and you can want to create some tangible evidence that that experiment was conducted, because later on, let's say you're doing your PhD or you're just doing a standard research project, you want to come back to that data later on in the future and reanalyze it, or you just want to do something with that data. So one of the ways that you could do it is to grab your lab book, so this is my lab book, and you'd write everything down by hand. But we can do better than that, in that we can create an electronic record. So how do we do this? Well, again, there's many ways that we can do this. What we're going to do in this video is we're going to use pandas and pickle. Okay, so two libraries to basically create a CSV file, which is a format of files that we can import into MATLAB, or we can use another Python program to extract the information out of the CSV files, or you could use Microsoft Excel. Okay, you can use RStat, Anaconda, anything that you want. So there's two more things that we need to bring in now. The first one is pickle. Okay, we also will need to import datetime. Okay, from datetime import datetime, because we're going to use this as the name of our files that we make. We're going to use the date. So we've got pickle, datetime, and we've also, notice up here, we've also got the pandas up the top. That's going to be how we control the data structure. We're going to create a data frame and then save that to CSV, to a CSV file format. Right, so we've got a function here, we've got a function there, experimental update function there. Let's create another function. We'll call this file, we'll call this experiment file, file. We don't need to run these two anymore. What we'll do is we'll just tidy this up, because now all we need to do is run the following, because we know the other stuff's working. So in this experimental file, what we want to do is first think about, well, how do we want to save the data? What information do we want to save? Well, what I want to save is the subject's initials, or the subject ID. So if you randomize your subjects to different conditions and you don't want to know their names, then you would use something like some number or some code. Let's see what Mike used in his paper. I think he used initials. Maybe he didn't put that into the paper there. Okay. So it's not in the paper, but anyway, I think in his thesis he used the initials of his subject, so then he could point out, okay, this was subject DF, or this was subject AG, if it was me, for instance. So I want, in my thing here, so let's create a doc string. I want to have this subject's ID, so we'll just use initials. Okay, I want to record the date of the experiment. And I also want to record the time of the trial. So when did that trial take place? And I want to also record the trial number. And I also want to record the frequency of the tone that we're going to use. So that will be the probe frequency. So in this case, we're just going to leave it at 1000 Hertz, 1 kilohertz. So that will be hard coded to 1000. Probe frequency, the volume, so 6, so the sound intensity, 7, we're going to use 7. Sound frequency, sound intensity, what else do we want to know? What window it went in, so the observation window. So was that 1 or 2? Did we present it in the first window, or did we present it in the second window? And then we want the subject's response. So the subject's response, did they think it was in 1 or 2? And then we want to see the correct, did they get it correct? So correct response. And then we want to, for now, we're going to add to this, but for now we want to do a correct counter, because in the next couple of videos we're going to look at controlling using 2 down 1 up methods, or 3 down 1 up methods, or adaptive staircase methods to control the intensity of the sound based on how the subject responded before. Remember, in Mike's paper, he used, I think it was a 4 down 1 up protocol, which converged on the psychometric function at 84.1%. So see here, for each experiment, the signal level required to produce 84.1% correct of a 1000 Hertz signal was determined using a 4 down 1 up procedure. So this meant that the subject had to get 4 correct in a row before the intensity of the sound went down by some level. If they got it incorrect at any time, just once, the sound level would increase by some step size. I don't know if Mike used a symmetrical step size or if he uses Carenbeck's asymmetrical step size, but we can get to that later. So, okay, we want to just start to put in that functionality now in our CSV file. So we need to know what was the correct counter. And we'll add some other things later on. So these are the things that we're going to need. So let's start working on this. So subject ID. So the easiest way that we can do this is just say, okay, subject ID equals, let's just, for now, we'll just ask the user, sorry, the experimenter, what is the subject ID? So subject, we'll just use initials for now. Okay. Subject ID, so the date of the experiment. So we'll do experiment date equals date time dot today. And we want to format this. So we want to format this into year first. Has to be a string, so year. We then want month, and then we then want the day. So we want to reverse the order of the day, month, and year for the date. Why? Because we're going to put the date into the title of the file. And by putting the date this way around, if you sort ascending or descending, right, by having the year first, it will go in order. If you had the date first and then the month and then the year, like how some people think of the date, think of dates, not our American friends, who usually put month, date in that order, month, day, year, you will notice that if you try to sort them ascending or descending, then they're going to be out of whack, out of order, out of whack. So experiment date, and we also want to have the experiment time. So we'll also do date time dot today dot format the time, and we now want this to be percent hours, percent minutes, percent seconds. Okay, years, dates, great. What else do we want? Well, we're going to need to have the file, we're going to have to save our file to some folder on our hard drive. What we're going to do in the future is create a GUI using a dialog box to navigate to that with our mouse. What we're going to do for this video is we're just going to hard code it. Now, what I have done is I've created what I've called a sandbox. Let's see if I've got that here. So I'll just bring it across for you. So as you can see here, I have on my hard drive, in this folder that I've got the program running, I've got demo sandbox. So what I'm going to do is bring across that path, the file path. So I'm just going to select it, Control C, and then Control V. So I'll call this the file, the base file path. This is not the file name, this is just the path. This is the pointer to direct to that folder. So you can see it's in users. This has to be a string, has to be, so it's in users, lab notebook, desktop programming, Python demo sandbox. Now I've called it sandbox because I know that anything that goes in there, later on I can delete it. Now I have to put an escape character here. So we have to, on Windows machines, we have to double backspace. Okay, so that's the file path. We'll also put one at the end because we're going to add our file name onto the end of the file path. But we haven't got the file name yet. We've got the date, that will be a part of the file name, and we've got the subject ID, that's going to be another part of the file name. For our file name, it will be the date backwards, followed by the subject's initials, followed by the task ID. So if it's a queued versus unqueued test, or if it's just a 2 down 1 up test, okay? Time of the trial number. So date of the experiment, subject initials, date of experiment. What we'll put here is we'll put 1.5. We also want the task ID. So this would be something like queued, or we're doing a 2 down 1 up protocol or something like that, or method of limits, or a staircase. So we need the subject ID, and then we'll put the task ID, and that's going to be very much the same. Input from the command prompt, we want to say task ID. Okay, we've got the file there. I think we've got enough to create the file name. So let's put this, so file name equals, and this is going to be the file path. That's a string, so we can string concatenate now, plus the date. So we have to put this after we get the date. So experimental date, so we'll convert this into a string, and we'll leave the experimental time as it is. That's fine. So we want that plus the experimental date, plus we want, in our case, what was the order? We want, I'll put this up here, date plus initials. Okay, so we haven't got experimental date plus subject ID plus task ID, plus we want it to save as a CSV file. So if we print this out, print file name, we should get as an output, we'll just make sure we run it, exp file. So this is just the function that we've called here, so we make sure that we call that function. We're passing no arguments to that function at the moment. We run this. We should get, hopefully, a prompt to say, hey, what's the subject ID and what is the, so we'll just say AG, that's me. Task ID, we'll just say queued, okay? And then we've got here, print the file name. So the file name will be C, users, lab notebook, desktop programming, Python demo, sandbox, 1903-31 AG queued. Okay, so we'll leave it at that. Now, what do we actually want to save in our CSV file? Well, that's what we've got here. These are the bits of information that we want to save. And we want to order our information so that in our spreadsheet or in our table, we're going to have some columns, and each column will have a title of that column. And I want each row of that column to be each trial that we run. So each time we run that main program loop, I want to get that information and save it to our file. So how do we do that? Well, we're going to need some variable or some structure to this. This is where pandas comes in. So we're going to say, experimental, experiment data equals pd, because remember we've imported pandas as pd, and pd.DataFrame. Data frames are two-dimensional data structures, so it's got an x and a y, whereas if you just use a pd.series, that's just a one-dimensional data frame, not data frame, one-dimensional data series. So in that data frame, now we're going to create a data dictionary that we're going to pass to the data frame. So to do this, we will need the following. So this is the title, and then we're going to put in the value. I think they call it key value pairs. So this is how we're going to do it. Data frame, I think it's a capital D. I've got a previous copy here because setting it up is quite a little bit tricky. So the first thing that we want, let's have a look at what we wrote here. We wanted, number one is the subject ID. So we'll just say initials. And for that, we want to put in the value, which is the subject ID. Okay. In the next line, what do we want? We want to have 1.5, the task ID. So we'll go task ID. And for that, we're going to put in task ID, which is what we typed up here. So we'll bring that back here. The next one, date of the experiment. And so that will be exp date. And then we want time, colon, and then we'll put exp time. And then we'll put, what's the next thing? Trial number, date, time, trial number. So we'll put trial. So we're just going to initialize this at the start. So we'll just put -1 at the start. Oops. No, that's fine. Trial. The next one that we want under there, trial number, is probe frequency. So we'll just put frequency, and then we know that this is going to be 1,000. But later on, if we're going to have different probe and target frequencies, then we can obviously create a variable and then call that up and add that into our file. So frequency, and then what's the next one is intensity. Oops, I need to put that intensity. And so we'll just leave this as 1 for now. That's the volume. Remember how we set volume before? That will be the volume of our probe. Observation window. What is it? Sound intensity observation window. So obs window. So this tells us which window it was presented in. So at the moment, we'll just say it was presented in 1. We will update that. Actually, we'll just make that -1. Oops. -1. So we know that that's not real. Obs window, and then we will put subject response. So subject response. So which window did they say it was in? We'll just say they did it in 1. Next one is correct. So 0 and 1. So what we're going to have to put up here is a comment to ourselves saying, you know, correct. Actually, we'll put it up here in our comments. So correct, 1 equals correct, 0, we'll start with 0 actually, 0 equals incorrect, wrong, 1 equals correct. So we'll encode it 1 or 0. Subject response will also be 1 if in obs 1, 2 if in obs 2. I've got the letter I there, that's meant to be the number 1. Correct. What else do we want? And then we want a correct counter. We'll just say core count. We'll just make that 0 because they've got none correct, no correct at the start. So this is our data frame. We have got the columns here. Each of these are another column. And the values that we pass inside here will be the rows. So at the moment, we've got a list containing just a single item. Okay. And so therefore we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns and 1, 2 rows. Because I'm counting the column titles as a row. So if we print this out, exp data, we should see an output. If I've done this correct, we should see an output of our data frame in our command prompt. Subject initials are a G. We're going to do a Q task. And there we go here. We've got 1 row. So see, data frame, the pandas, doesn't include the column titles as a row. So that's fine. So we've got initials, task ID, date, and then we've got, it truncates Subject, response, correct, correct, count. We've got 11 columns and 1 row, so this is good. We've got the data structure that we're initializing here. What we haven't done is we haven't saved that to our file. So the way that we do that is we then say, okay, dear pandas, please take this data frame, and we want to go and send it to a CSV file. And so now to put it into a CSV file, we need to give it some arguments. Firstly, we need to say, what is the file name? So that's what we created up there. So we have to tell it, hey, this is the file path and the file name that we want. And the other thing that we want to say is, you see here, it's given us the row number on the left-hand side there. See how it's printed out 0? Can you see that? I might make this a bit bigger. Properties, font, well, it's already 16. Oh, I'll make this a little bit bigger. So you see how here it's got the number 0 here? We don't want to include that there because our trial number will give us the row number. So we could say, Pandas calls that the index. So we can say index equals false. We don't want it to print out or to save the index. So if we have a look at this here, what I'm going to do is I'm going to bring up that folder. We'll bring it across here. And if we do it correctly, or if we've done it correctly, we should see the file appear here. Subject name. AG, we're going to do a Q task. There we go, and here we go. It's appeared here in our folder. If we double click on this, hopefully we should see a CSV file that contains 11 columns. So there's the title of our thing there. Let's have a look. My Excel's being a little bit annoying. There we go. We've got it here. So we've got the initials. Quit mucking around. Okay, we'll just make it a bit bigger. Got the initials, the task ID, the date. So see, it's taken the initials that we entered, and it's taken the task ID that we entered. It's got the date, it's got the time, it's 12 o'clock. I've missed an hour. We've gone into summertime. Okay. Time, the trial number, the frequency, the intensity, the observation window, the subject response, and the correct response, and the correct count. Good. So now we have the CSV file. That is going to be a log of the experimental progress. So I'm just going to shift this across to the left here. And what we're going to do is we're going to give ourselves a backup just in case. So what we're going to say is we're going to say try. We're going to try to save that. And we're going to put an except in here. So except debug problems saving file. So what a try except statement does is Python will attempt to do what's in here, but if an error is created or if it can't do it, it will then run what's in this except conditional statement. And if it can't save it, it will then print out this debug statement. So we've got now a CSV file. But if there's a problem with making the CSV file for any unknown reason, what we're going to do is we're going to try and see if we can save a second, more simpler file. And that's called a pickle file. And if you don't know what a pickle file is, I've got a series of videos, one of the videos in my other series using pandas for psychophysics, using pandas for experiments, it's Psychopy and Pandas. We go through a little bit into what pickling is. Basically, you're serializing the data and you're basically doing a binary dump. So what we want to do is we want to save a pickle file. Python and Pandas can unpickle data quite easily. So if the CSV file doesn't work, but the pickling process does work and you've saved the pickle file, then you can you write another program to decipher that serialized data. So we're going to go with open, and we are going to open the following file. So file name plus we're going to have to include PKL, because pickled files are .pkl files. And what do we want to do? We want to write this file as f. So with open, we're going to open this file name. We're going to add to it the .pkl, so it's going to be .csv.pkl, and we're going to write to this. We want to then do what's called a pickle dump. Pickle.dump. And what do we want to pickle dump? We want to pickle dump the experimental data. We want to use this with open. So we want to use that. And what we want to give it is the highest protocol. Pickle.highest protocol. So this should give us the best chance of doing that. And we'll say, okay, debug file saved. File saved. Oops. Okay, so what we'll do, we'll bring back up our folder. We'll delete this guy out. Okay, we'll then come back here, run this, and if it's worked, we should now get two files out, our CSV file and our pickle dump. Subject's initials is AG, and we're doing a queued task. Okay, file saved, and here we go. Here is the CSV file, and here is the pickle file. So if we go here and we open up this file, it should be exactly the same as what we have before. The time is obviously different now, it's 12:05, but we should have exactly the same information as what we had before. Now, I haven't written a program to deconstruct the pickle data, but we can do that later on if you want. Okay, so now we'll leave this video here because what we have is a program that will save a file template as a CSV file. And so now what we need to do is figure out a way of saying, okay, we have to initialize our program now. We have to now control the experiment itself by changing the response, the intensity of our signals, and we have to monitor for the keyboard input. We have to save all this information, and we also have to start thinking about, well, what happens if we always play the stimulus in the first time window? Your subject is going to recognize pretty quickly, hey, it's the first time window, so they're going to get 100%. So we're going to have to start to introduce variability or randomization as to first time window or second time window. 50-50 split. There's a 50% chance in each of those windows. That's what we're going to do in the next video. So until then, give this this latest experiment a crack, and I'll see you in the next video. See you then.